Okay, look, we've considered this circuit. We've considered this circuit in terms of finding the Thevenin impedance. We've looked at two different approaches. Note again, we've got an independent source here. So we said that we could find the short circuit current and we could divide that into the Thevenin voltage, or we could actually zero all our independent sources and look at the impedance looking in at those terminals A, B, all right, having zeroed everything inside. All right, well, yeah, that's fine, but I just want you to think a little bit here, all right? Now, if I'm finding the short circuit current, then in the calculation of the short circuit current, well, I've got this source, haven't I? And this source actually has an angle associated with it. Yeah. Is that going to be a problem? Remember, when I'm calculating the Thevenin impedance, zeroing this and just looking in here, this is gone. It's replaced with a short. So does this angle have any bearing on anything when I'm actually trying to calculate the Thevenin impedance? So that's what I want us to think about here, to make sure that we really do understand that. And so what I'm going to do is I'm going to redraw this circuit. Okay, so here it is, and I've got my resistor here, I've got the inductor, its impedance is J4, and I've got my capacitor sitting over here, and this is my minus J10, and here are my terminals A, B. All right, now let's think about this. Let's not actually specify as 20 angle 30, let's just write this perhaps in a generic way, and we'll just say it's got a value E, all right? And we'll see if we can write down some information here with respect to that E. All right, so let's go. The Thevenin voltage, V Thevenin then, is what? Well, it's going to voltage divider, isn't it? And so it's going to be this guy here, which is what? I'll write it in polar. That's a 10 at an angle of what? Minus 90. And that's divided by what? Yeah, it's divided by the sum here, which is what? 3 plus J4 minus J10, okay? And that's what? Multiplied by E, is it not? So this is then equal to, this will be 10 angle 90 divided by, I'm going to put this in its polar representation, which is 6.7, and that angle there is a minus 63.43, okay? And again, multiplied by E. All right, let's take this just one more step, and what do we have? We have V Thevenin is equal to 1.49, and my angle here, just bring that up, is a minus 26.57, and that of course is multiplied by E. All right, let's see now if we can determine what the short circuit current is. So I short circuit, so that means we're putting really a short across here, and we're trying to calculate that current, I short circuit. Okay, no current flowing actually through this. So it's an easy calculation, isn't it? It's really just going to be equal to E, is it not? And that's going to be divided by the 3 plus the J4. All right. If we represent that in polar form, this is simply going to be E divided by, that's a 5, and my angle there is a 53.13 degrees. Okay, final step then is that the Thevenin impedance, of course, is the Thevenin voltage divided by the short circuit current. Let's put that information in. What do we have? We have 1.49 angle minus 26.57. That's multiplied by E, isn't it? That's divided by my short circuit current, which of course is E, and that is divided by what? 5 at an angle of 53.13. Now you notice what happens here? This E cancels with this E over here. And so therefore we can now say the Thevenin impedance is really equal to what we had before, which is a 7.45, and that's at an angle of 26.56 degrees. All right? So I just wanted to show you that, and that's basically why it didn't really matter whether that source had an angle associated with it, because basically in that calculation, the Thevenin bit has the E in it, and of course the short circuit current bit has the E in it, and of course they just simply cancel each other out.